Again, here we'll start off by verifying the conditions or verifying the assumptions for L'Hopital's rule to make sure we can apply that technique to this problem. So we'll take the limit as x approaches 1 of the natural log of x, which will give us the natural log of 1, which is equal to 0. So the first function, the numerator, meets that condition. Then we take the limit as x approaches 1 of x minus 1 cubed, which will give us 1 minus 1 cubed, or 0. So again, the conditions are met. So the next thing we want to do is differentiate both the numerator and denominator separately. So we'll take the derivative of the natural log of x, which will give us 1 over x, and the derivative of x minus 1 cubed, which will give us 3 times x minus 1 squared, times the derivative of that interior function. But in this case, the derivative of x minus 1 is just 1, which means we can rewrite our limit problem as the limit as x approaches 1 of the numerator times 1 over what we had in the denominator, 3 times x minus 1, that quantity squared. So again, all I'm doing here is just taking the numerator, the derivative of the numerator over the derivative of the denominator. I'm just writing it as the product of two fractions so that I don't get a complex fraction. So just a little bit of algebra to rewrite that. Or we could combine that, simplify that to rewrite this as the limit as x approaches 1 of 1 over 3x times x minus 1, that quantity squared. Now, if we try to evaluate this through direct substitution, we'll get 1 over 3 times 1, so 3, times 1 minus 1, which is going to be 0. So this is approaching this form 1 over 0, which indicates that we have a horizontal asymptote. So now we just need to know, is the limit infinity, negative infinity, or does not exist, because it's approaching two different directions from either side. So taking a look at a graphing calculator, we can plug in the expression itself and then graph that function to see that as we approach x equals 1 from the left, we're headed to positive infinity. As we approach x equals 1 from the right, we're headed to positive infinity, which means our limit is positive infinity.